Welcome! Video 7.6b. We are about to look at some molecular formulas and how to calculate a molecular formula when given an empirical formula. So first and foremost, you gotta know the formula mass. Remember, we are measuring these in atomic mass units. Yeah, we have to determine the empirical formula first and foremost. Then we're going to use these equations. So get them down in your notes. You need to know this equation right here. The empirical formula is a x, which is a number, a whole number multiple, times the empirical formula. That will give you the molecular formula. This relationship also exists for the masses of the two formulas. So basically, if we figure out what this x is, this whole number ratio, we can use that to get the simple formula and the actual formula. Let's dive into one of these problems. Here we are given the molecular formula of diborane is unknown. It has a mass, however, of 27.67 grams per mole, and its empirical formula, or the simplified version, is BH3. We want to know the molecular formula. Well, I'm going to imply here the guess method in solving problems. So if you have not used the guess method before, write it down, G-U-E-S-S, and I'll walk you through it. G is going to be your given. So I'm going to start with everything that I am given in the problem. I'm given the molecular formula mass. I'm getting that from right here. It's 27.67. The empirical formula is BH3 right here. I am also given basically the empirical formula mass because I can look on the periodic table. I see boron has a mass of 10.81 AMUs and each oxygen has a mass of 1.01. I have three of those. Together, I can get the empirical formula mass. That's my given. My unknown. Well, what don't you know in this problem? Well, I know here that my unknown is going to be the molecular formula. That's what I'm not sure of. So I'm going to be looking for that. I usually put a big question mark around what I'm looking for. And then I'm also going to be looking here at my equations. What equations do I have to deal with? Well, previous slide, we just gave you these two equations. Empirical formula is going to equal the molecular formula, times it by the x, and right here is my same equation, but all I'm using is mass. That's the only change there. So what I want to figure out here is my next, which is S, which is going to be my substitute. I'm going to substitute in the equations, my givens. And I'm looking here. I know formula mass. So I'm looking right there's formula mass. So I know that. I know the empirical formula. So I have this. I'm given this. I also know the empirical formula mass. Well, right here is the empirical formula mass and my molecular formula mass. Sorry, I underlined the wrong thing there. But I know those two. I do not know my x. That would be my unknown right now. I don't know this. And I'm looking for this part right here. I'm looking for the molecular formula. That's what the problem is asking me to find. So, basically, I can solve for x, use it in this equation. I know this value, and I can calculate that value. So I just kind of mapped out in my head there my plan of attack. So let's go ahead and get to substituting in here. I'm going to substitute x equals the empirical formula mass. I'm using this equation right there, times, is equivalent to the molecular formula mass. And then I will substitute in my values. I do not know x still, that's why it's underlined in red. My empirical formula mass I have right here as 13.84 AMUs. is equivalent to my molecular formula, which is 27.67 grams per mole. Now, I'm given here two different units. And remember that grams per mole is the same thing as the formula mass. That's just assuming I have 1 mole of this. So let's just assume I have 1 mole of my compound and it's grams per mole. Gone ahead and assumed this is grams per mole. I'm going to solve for my unknown now. Divide both sides by 13.84 to get my answer here. X is going to be equivalent to 1.99927. That's basically rounded to 2. So I now have my 2. I can use that in my next equation to solve here for my last step. So I have my equation, which is going to be 2, which is x, times the empirical formula, which I was given as BH3, is going to be equivalent to the molecular formula. And again, I'm given these equations, so you have them given to you, and it's right here. Empirical formula equals the molecular formula. I'm just going to multiply through by 2. Now, when I'm doing this, this is being multiplied to the subscripts in the formula. So I'm going to end up with a B2H6 as my diborane molecular formula. And that is how you will calculate the molecular formula of a compound.